All right, sixth grade Excel, lesson number 47, comparing fractions with unlike denominators in less than and greater than problems, and in true and not true number statements by setting up equivalent fractions. Now I'm going to show you how to set up equivalent fractions, but I'm also going to show you a shortcut. So stay with me and pay real close attention because these are going to be the easiest problems you've ever done in your life. Here we go. When comparing fractions where the differences are large, it is fairly easy to tell which is the largest or the smallest. So in other words, if we have 1/4 being compared to 9/10, it's real easy to say, well, 9/10 is bigger because that's almost a whole, and 1/4 is hardly anything. You know, it's a fourth, so that one's pretty simple to tell. But when the differences are smaller, other methods can be used. What if we have 8/11 being compared to 7, or let's go 9/12 or something like that? Which one's bigger? Well, those are really close to each other, so we can't just glance at them necessarily and know the right answer. Here's 2/3 and 3/4. Which one's bigger here? Well, what they did is they changed 2/3 to 8/12. We're finding a common denominator here, and 3/4 to 9/12. So just like when we add or subtract fractions with unlike denominators, what they're telling you to do is find a common denominator between the 3 and the 4, and then find what each fraction is equal to with that denominator. Then the comparing of the fractions is very simple. All you have to do is look at the numerator to see which one's larger. Let me show you how they did this by going through the steps. We do the multiples of 4, the bigger of the denominators. First multiple of 4 is 4. Does 3 go into 4? No, it doesn't. How about the next multiple of 4? 8. Does 3 go into 8? Not evenly, right? How about the next multiple of 4? 12. Does 3 go into 12? Yes, it does. So we're going to use 12 as our common denominator on both sides. 3 times 4, kind of working my way backwards here, is equal to 12. So 2 times 4 is equal to 8. 4 times 3 is equal to 12. So 3 times 3 is equal to 9. Now I'm comparing 8/12 and 9/12, and the 9 is obviously bigger, so I put a greater than or less than sign like that, showing that the 9 is the bigger fraction. Now that's a lot of work, and I'm going to show you a little trick for that coming up here, but for right now we're going to do it that way. All right, number 1, we're going down to the next part. 4/8 is equal to 1/2. Oh, this is comparing, can't even hardly tell here, huh? Okay, we're comparing 4/8 and we're to 5/10. Both fractions are being changed into 1/2, and when they're both 1/2, they are equal to each other. Here's another fraction comparison problem, 5/6 and 3/4. Well, 6 and 4, the common denominator is 12. 6, 4 doesn't go into 6. 12, yes, 4 goes into 12. So the 12 is used as the same denominator. 6 times 2 is 12. 5 times 2 is 10. 4 times 3 is 12. 3 times 3 is 9. Now I can compare the 10 and the 9, and the 10 is bigger. All right, let's do one problem like this. We'll do it together, and then I'm going to show you the simple way to solve these problems, okay? So 8 and 4. What's the common denominator of 8 and 4? Well, that would be 12, right? No, that's not 12. It's 16. I'm sorry. No, that's not even 16. That's 8. We can use the number 8 because the first multiple of 8 is 8, and 4 does go into 8. So 5/8 is equal to 5/8, obviously. 4 times 2 is 8. 3 times 2 is 6. Now, which one's bigger? The 6 is bigger, and so I would put my sign like that. Now, here's the shortcut for solving this. Go ahead and write that on your paper. All I have to do is take the denominator and multiply up to the other numerator, and I can just compare the answers. So 8 times 3 is 24. 4 times 5 is 20. Which number is bigger, 20 or 24? 24 is bigger. That's all you have to do to compare these fractions. We actually are finding a common denominator. In this case, my common denominator is 32, not 8. But as long as the denominator is the same, even though the fractions aren't simplified, it still works. And so 20 here, 24 there. This is how you show your work on these types of problems, by writing those two numbers above the fractions, and then of course writing your symbol in there. Okay, the next one says 3/7, 1/2. So everybody on your blank spots there, write 3/7 here, 1/2 here. Of Go ahead and do that. Now let's do this together. Multiply up. You always go up. Start down and go up. 7 times 1, everybody write a 7 right there. 2 times 3, write a 6 right here. Which one's bigger, 7 or 6? Well, 7's bigger, and so I'm going to put the symbol like that. All right, the next one is 5/6 here. So write 5/6, and that says 2/3, so write 2/3. And now pause the video, do your show work like I did here, and then fill in the symbol in the middle, the greater than, less than symbol, and then turn the video back on to hear the solution. Okay, 6 times 2, you should have written a 12 up here. 3 times 5, that's 15. 15 is bigger than 12, so you put your symbol like that. Alrighty, moving on. Now we're going to do the exact same thing, except we're going to decide if the statements are true or not true. We're going to write T or NT for our answer to these. We'll do the first one together. 3 times 5 is 15. I want to see this on your paper. And by the way, when you guys compare work and consensus, everybody should have the same show work on these problems. 6 times 2 is 12. Which one's bigger, 15 or 12? Well, 15 is. So the symbol should look like that, right? Well, the symbol does look like that. So we're going to say that that's true. All right, pause the video. Try 7 through 11. I'm going to let you do the rest of these. Turn the video back on when you're ready for the solution. 3/8 and 3/6. You should have multiplied 8 times 3 is 24. 6 times 3 is 18. Is 18 equal to 24? No, it's not equal to each other. Not equal is the correct symbol, so that is true. Don't put not true just because it's a not equal sign. That is actually true. 12 times 1 is 12. 3 times 3 is 9. Which one's bigger? The 12's bigger, right? Is that the symbol you see here? No, it's not. So we're going to put not true. Sometimes it helps when you write the symbol in between, showing what it's supposed to look like. Then it's real obvious if the symbol is correct or not. 12 times 1 is 12. 2 times 6 is 12. 12 is equal to 12. Is that the correct symbol? Not true. 8 times 1 is 8. 2 times 2 is 4. 8 is bigger than 4. I see the same symbol. That's true. 9 times 1 is 9. 4 times 3 is 12. 12 is bigger than 9. I see the same symbol there, and so I put that it's true. All right, thanks for watching.